So in this video, we'll talk about how to determine whether or not a function is differentiable at points, and then how to estimate the value of a derivative from a graph. So remember that a derivative is defined to be, informally, the slope of a tangent line at a point. So sometimes you'll be asked to determine if a function is differentiable or even where a function is not differentiable. So differentiable means that the derivative exists. So differentiability is really the ability to calculate a derivative. So a function is said to be differentiable if the derivative exists on each and every x value in the domain. So we have to figure out, okay, well, where does the derivative not exist? So a function will be not differentiable at a specific point if any of these three conditions are met. So if f is not continuous, so any place f is not continuous, it would also be not differentiable. So not continuous means not differentiable at a point. And by the way, these notes are not in your notes packet, so you'll need to take these notes on your own paper. If f has a corner at a point, then that function is not differentiable at that point. P-O-I-N-T. And then if a function has a vertical tangent at a point, then that's another place where the function is not differentiable. And it's not that it's not differentiable for the entire function, it's just not differentiable at that specific point. So here's an example of a question that you'll be asked in Delta Math. It says, use the graph of the function f of x shown below in order to determine all the values of x on the open interval from -9 to 9. So what that means is you don't have to worry about -9 and 9. We're not including those in our determinations. So on that open interval, where is the function not differentiable? So I'm going to be looking at anywhere where any of these three conditions might be met. So first of all, let's look for places where the function is not continuous. So not continuous, we talked about that a couple lessons ago. So it looks like it wouldn't be continuous at this point because there's a jump. And then I don't see any other asymptotes or holes. So we would say that f is not differentiable at x equals -1. Because the function f is not continuous at those points. So if someone were to say, hey, what's the value of the derivative at -1? You would say it doesn't exist because the derivative does not exist at x equals -1. The next place you'll look to see if a place where the derivative wouldn't exist would be at a place where f would have a corner point or a sharp turn. So corner points look like elbows or like points. So there's a point here and there's a point here. So that means that the derivative does not exist or the function is not differentiable at x equals 1 and x equals 6 because there's a corner point. Okay, then finally I'm going to find my last place where the function is not differentiable anytime there's a vertical tangent lines. So when I'm looking for a vertical tangent line, I'm following the path of the curve, and I'm trying to see if there's a place where a tangent line drawn at that point would be temporarily vertical. So it might help. It's going to be hard for me to show on the computer, but I'll do the best I can. It might help if you, grab a line. Might help if you draw a line and try to drag it around your curve. So like right there, it looks like horizontal, but I want to see if I take my tangent line, is there anywhere I can match it along the curve where it looks like the curve might be temporarily vertical? Ooh, right here. Look at -6. If I draw a vertical tangent line at -6, it looks like my curve might be temporarily vertical. So I would say that at -6, it's not differentiable. Because I have a vertical tangent line there. And then I'm going to take my tangent line, my vertical tangent line, and try to drag it along my curve to see if there's anywhere else my curve might be, and I'm dragging and trying to match up, see if anywhere else my curve might be temporarily vertical. I'm not seeing it. Looks like it might almost line up, but not quite, because it doesn't ever temporarily change to vertical tangent line. So nope. So it looks like my only places where my function is not differentiable are at -1, 1, 6, and -6. Okay. Then you'll be asked to use a graph to determine all the values of x in the open interval from -9 to 9, for which the function is continuous but not differentiable. So I look at these three things. So I know a function not being continuous will make it not differentiable, but I'm looking at a place where the function is continuous but also not differentiable. So that means I'm going to be looking for the places that have the corner point or a vertical tangent line. So let's look for the corner point first. So it looks like I have a corner point right here. I'm going to have to draw it. So there's a corner point and a vertical tangent line. So there's a corner point at x equals -2, and then a vertical tangent line. Let me draw a vertical line. Try to match it up to see if there's any place where the graph is temporarily vertical. So I'm dragging, oh look, if I draw it right here, it looks like the graph kind of gets vertical for a little second at -7. So at x equals -7, there's a vertical tangent line. And is there anywhere else where I can drag this vertical tangent, this vertical line? Oh, looks like right at 2. At 2. There's another vertical tangent line. Vertical tangent line. And then anywhere else? Nope. Not seeing it. So function is not differentiable at x equals -2 because the function is not continuous. Or sorry, if there's a corner point, and then not differentiable at x equals -7 and x equals 2 because there's vertical tangent lines there. Then the other thing you'll have to do is you need to be able to estimate the value of a derivative from a graph. So you won't have to exactly come up with a specific number, But just I'm reminding you again, I know I've told you this probably about 7 times right now, but when we're estimating the value of a derivative, we're estimating the slope of a tangent line. So whenever I'm asked to find a value for f prime of 5, that means what that question is asking, it's saying is what is the slope of the tangent line at x equals 5. So at x equals 5, what's the slope? So at x equals 5, here's where it meets up on the graph. And then if I were to sketch in a tangent line, I would use like a line right here. And it's hard to kind of get exact value, but look at your options. My options are f prime of 5 equals 0. Well, is this tangent line horizontal? Because that's what 0 slope looks like. No, so it's not 0. Is the derivative less than 0? Well, I look at my tangent line, I see that there's a negative slope. And negative slopes mean less than 0. So it looks like my derivative is less than 0. Let me just double check the other ones. This one would say that my slope of my tangent line would be greater than 0 or positive. And that's not true. And then does f prime of 5 not exist? Well, this function, there's no corner piece, there's no vertical tangent line, and it is continuous at x equals negative 5. So it looks like my option is that f prime of 5 is less than 0. Okay, the graph of a function f is shown below. Which statement best describes the value of f prime of 3? So I'm going to look at f prime of 3. I'm going to sketch in a tangent line. Looks to be pretty horizontal to me. Then I'm going to pick this statement that best describes this tangent line. Well, it looks like it's horizontal, and tangent line with a horizontal tangent line has a slope of 0. So I would select this box. The graph of a function f is shown below. Which statement best describes the value of f prime of negative 1? Well, at negative 1, if I were to sketch in a tangent line, it's like I would be drawing a vertical tangent line. Well, if there's a vertical tangent line, that tells me that f is not differentiable at x equals negative 1. And if a function is not differentiable at x equals negative 1, then what that tells us is that the derivative does not exist at x equals negative 1. So I would pick this option. Then we have this function. The graph of the function f is shown below. If m is the slope of the tangent line to the graph at x equals negative 4, which best describes the value of m? So here's negative 4. I'm going to sketch in a tangent line. Looks like I'm drawing a line with a positive slope. So the slope would be positive. I would pick that option. And then, finally, the graph of the function f is shown below. Which statement best describes the value of f prime of negative 6? Well, at negative 6, it's right here. Sketch in my tangent line. Looks to be horizontal. So f prime of negative 6 would be 0.